Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Dual 506 belt drive turntable. It's a client unit. He brought it to me. He says it's got a problem. Problem being loud hum. He can't figure out why there's such a loud hum. I don't know if he said one channel or both channels, but we'll investigate that. And he also mentioned it probably has the refit caps in there, so we'll address that as well. But first off, let's just have a look at it. It's a nice, really nice example. I guess his plan for this one is he wants it just fixed up. He doesn't want it completely overhauled. He just wants it working. He's going to pass it on to somebody else. And it's a little rough shape. It's got some paint missing right here and here. Inside's nice and clean. The lid, though, is a little beat up. It's got some nasty scratches here. Other than that, it's okay. Some scratches here, but the worst part is it has this here. So I don't think I did that. I hope I didn't do that. That looks pretty nasty. So we'll see if we can get some UV resin in that crack, and maybe we can get that set up and maybe strengthen this a bit so it's a little stronger than what it is now. It does work. The lid is still there, it's holding, but you know, that makes me nervous. So we'll see if we can do something with this, and then we'll so let's hook it up and see. We were missing, let's see here what we have. Got all our cables, they're all knotted up here. A lot of times when it's you got a bad ground, you either a bad hum, you have open ground somewhere. The ground, there should be a spade lug on there that we can put that on there. One thing we need to do is just a quick continuity test on these cables, just to see if we have okay. We got 14K in, and it's really, here I'll show you. You can see this. Hope you can. 14K, and it's not stable. It's jumping all over the place. So we do have a poor connection. There, it's settled at about 680 ohms, which is what I would expect to be the cartridge resistance. Now let's try the other channel. And this is the same thing. It's jumping all over the place. 25K. Yeah, so we got a broken connection somewhere, or a very high resistance connection. Let's put it that way. So let's get an amp and try it. Okay, so I got my little trusty realistic mini amp here. It does have phono input, magnetic phono input. That's why I use it for testing all the time. It's small, and it doesn't need to be anything spectacular. It just has to have the amplification. So there's full volume with nothing connected, and I can barely hear the amplifiers. So let's turn it down. Which is right and left on these? I don't even know. Black and white, right and left. Okay. Okay, it's quite loud on the right channel. Actually, which one is it? It's on both. Yeah. Is there a broken wire here? Seems like maybe it's broken right here. Boy, I don't hear crunchy noises when I move it. Just going to try bending these the outer shield. Sometimes it gets loose. Just going to try bending them in a bit just to make better contact on the ground. Could also be dirty inside there. I see a lot of dirt inside, so let's see if this helps. No. Grabbing the cable, if grabbing the cable increases the volume of the hum, that tells me that this cable is not grounded, and it's allowing the voltage that it's picking up off my body to go right into the core, it's the center core. So there's definitely a problem right here. See, I touch the ground and it goes quieter. So it's definitely broken here somewhere. If I grab the cable and it made no difference in the hum, then we know that the cable is grounded and it's shielding the internal conductor against my body. But this is wide open. So what we need to do is replace either the cable or replace these ends. Typically they break right here where there's all the flexing, and if they ever get pulled, sometimes you can pull them and you can just visually see if it stretches. You pull on it, and if it stretches, you know that the coppers aren't connected, but I don't see that right here. So maybe what we could do first is we could chop these ends off and put some new ones on. Or I could just go and get an entire new cable. Phono cables are a little tougher to just up and replace because they have to be fully shielded. If they're not fully shielded, you're going to get hum pickup. Let me think about this. I'll open this up and I'll test for continuity on the grounds. And I bet you they're both open. Alright, so I went and dug through my stash of RCA ends, and I have these cheap Chinese ones. I'm not happy about these, so I don't think I'll be using any of these for replacement of the originals. And then I got the higher end gold ones, which are better, but they don't fit the cable properly. They have a huge hole and they'd be flopping on the end. These would be better just because they're gold plated and they make a better connection, but still not good enough. So what I'm going to do is I'm going to replace the entire cable, and I'm looking for a replacement cable here, and I've been just going through and testing different cables to see how they reject hum. And this one's not bad. This one's, let's see, you can hear the hum from my body. But this one's actually not bad. But interestingly enough, I did find another one. This one here. I was looking at this one. This is an AV cable, but still I could get rid of the V part and use the A. Look at this one. How much hum this thing has. It's like it's not even shielded. And then it breaks out into feedback. Yeah, this is garbage. I don't know why you would use this for anything. I should just cut it up and throw it away. But you can use the phono input as a tool to test how sensitive your cables are, or how well they do at shielding. Let's try this one. That one's not the greatest. I think that first one is the best so far. Here's another one. This one's actually pretty good. This one's pretty quiet. So it's toss it between those two. So like I said, I'll just replace the entire cable. Looks like we have about 3 feet here. You don't want to go any shorter. And we'll get rid of this factory cable and replace it. Here's a look at that cable that squealed because it was so bad. Let's just try, let's remove some of the jacket here and see how much insulation it has, or how much shielding it has on the ground. I bet you it doesn't have much. Yeah, look at that. So we got an exposed wire, and the grounding shield is running alongside of it, which should be fully wrapped around, but it's not. This is why the cable is terrible, because it's not shielded. It's just a 2-conductor cable. Pathetic. That's probably, yeah, that's not good at all. Okay, I'm going to attempt repairing this. Never done this before. I don't know if it's going to work or not. My plan is to use cello tape to tape over the cracks. Now the sellotape's going to act like kind of like a wall for the resin. What I'm planning on doing is putting tape over the cracks, and then hopefully I can get some resin, some UV curing resin, to flow into the cracks and stay within the cracks. That's what the tape is for, to keep it in the crack without it going everywhere making a mess. I'm going to try this. I've never done this before. I don't know. Maybe somebody else can chime in and tell me a thing or two about this. So, got the inside done. Let's cello tape the outside. Now I don't know how far the resin will flow within the crack, but I'm hoping it'll make a improvement. I'm hoping it's going to be enough to add some strength. Okay. So I got the outside and the inside of the crack covered with sellotape. Now I need to figure out how to get UV cure resin into this. So I can, probably the best way would be a syringe. And if I stand this up, I could get gravity to help me. I'll see if I have a syringe here. I don't think I do. I'll run to the store and buy one. But it has to have a nice small needle, and I can get it in this because I can lift it and I can make a little bit of a gap there. So I did find a syringe in my wife's crafting supplies, but I didn't find any needles. Now I can use this. This is a tip for a flux dispenser, and that'll work. So I have myself a little syringe. This is a really coarse tip. Really, you see how big that is. What I can do is just crush this down with a pair of pliers and make it very thin, just enough to get there. I crushed it down. You can see that. And now I can get it into the crack and pump that full. So let's do that. Okay, I don't know how well you can see this, but I do have this. I can now, and drop it. So I do have this that I can, now if I just gently, and I'm also making a mess. I think that's all I'm going to do. I'm going to clean up this excess and just let this, I need some, it's not flowing in the way I'd like it to. It's staying right around here. But Maybe if I open the crack up, I can get it to flow down inside. Yeah. It'd be better if I could suck a vacuum, suck the air out, and then put the resin back, and it would go back into fill the cracks. But it's not. It's not possible the way I'm doing this. This resin is just too thick to flow down inside. So I think what I got now is I can just cure this part here. Make sure I got it cleaned up properly. Just want to close the crack, clean it up, and then cure it. So let's try this. And then it might not hold at all. It might just crack the first time we use it. Looks like it's already holding. Yeah, it's no longer moving. Well, be easier if it was just like a star crack and it had no end to it. Like, well, we'll see how this holds out. That actually strengthened it quite a bit. Like, it doesn't move when I pull on the bottom corner. It doesn't move out anymore. And I think that'll help hold the lid. But like I said, this might just fail in no time. I really need to get these cracks bonded with the UV resin, but there's no way to get the resin in there without using some kind of a vacuum to suck the air out and then get the resin back in. But this actually worked. I'll clean it up a little bit. So here's the cartridge, and it actually looks pretty good. One thing I had the client do before, I told him before bringing it over, make sure you check here for any bad connections, because this can cause a lot of problems. I think I need to release a set screw here. Let's keep going. How far does that set screw go? There we go. You gotta remove quite a bit of it to get it to unlock. Okay. Can barely see them, but there's 4 contacts here. See these 4 contacts at the back of the head shell, or the cartridge carrier, and they come in contact with 4 pads that are underneath, and that's what I told them, you need to get in there and clean those, because this is notorious for these duals. They lose connection at these. But he said he checked them, and there's the cartridge number. Can I read that? Looks like a TKS 49S. I don't know if that's a good cartridge or not. Yeah, so I'll check with an ohm meter here just to make sure we have continuity for both our coils. I'm sure we do. And I'll make sure I clean this with the cotton swab and alcohol, because I think it's, if I'm correct, I think it's silver plated and it does corrode, so that can cause problems. So let me check that. Alright, testing for continuity on the cartridge. It's pretty simple. You got 2 coils, 4 wires. Now you would think that they'd have left and right channel. One side would be left, one would be right, but that's actually what they do is they wire these diagonally. So top here and bottom here, and if I measure across diagonally, I get a measurement 654 ohms, which is normal. And if I flip this over, we measure the other coil. $654. Okay, so this cartridge is good. It passes the continuity check. Both coils are there and present, and they show up on my ohm meter. So there should be nothing wrong with this cartridge, as long as the stylus is intact and it's not damaged. It should work just fine. So we can put that back in, and let's focus on working on the inside of this thing. Cartridge installation on these duals is kind of unique. It's not like the head shells that you twist on the collar. You just put it up in place, click the lever forward, and it should secure it. And then you drop this set screw down, and it locks the handle in place so it can't move. So I'll just drop the set screw down so it's flush, and that's it. Belt drive platter. He said something about this mat, and I think double-sided sticky tape is kind of worn out. We can remove that, and we can replace it with some fresh double-sided sticky tape. It's just to hold the mat in place so it doesn't slide around like this. So you center it, and that should be good. Okay, let's get this out of the way. This belt drive, here's our motor. There's a lock. You can give it about an eighth of a quarter turn, eighth of a turn, and it unlocks. And you can lift the platter away. There's a copper spring there, you don't want to lose that. And then we have our belt mechanism. Belt. Well, it's not the best condition. It's pretty soft and soggy. Let me put some power to this thing. Okay, queuing's up. It's got some good .45. Yeah, I think, you know what I'm going to do? I'm just going to clean this belt. Oops. I'm going to clean this belt and then see how it performs. It's definitely seen a lot of miles. I'll give it a good clean. Let's see what kind of belt it is. I just bought some belts too. We'll see how this one fits. It's probably, yeah, it's way too big. I don't have any of this size, 14.5. Oh boy, I don't have any of that large. I think this belt will be okay. I'm cleaning it with isopropyl, and it's coming pretty clean. You can see the filth that got off there. This belt here, I did have a 15 in stock. This is a brand new belt, but it's been sitting for quite a while and it's got a kink in it. So I don't want to use this on a turntable because every time the kink goes by and it'll get a little wow and flutter. I think we'll just stick with the old belt and run with it. They're so easy to change. If the new owner of this turntable really wants a new belt on it, they can order one 14.5 and put it in. It's pretty simple to do. It'll take you like 3 minutes. Just pull the platter off, change your belt, put it back on. So I'll clean everything up here, and yeah, we'll clean everything up and then I'll get that belt back on. Here's a look at the original belt, and it's running pretty stable. It's not speed variation very much. You can see it's running pretty good. I'm going to try the other belt I had just to see how it matches. Here's the 15-inch belt, the new one I had, and it's actually running better than I thought. Problem is it's a little too big, and there's slippage when you first start the motor, so it takes a while for the platter to spin up, but it would work. You can see a little bit of a deviation there, but the other belt was better, so we're going to run with that one. Alright, with the tone arm locked in place, platter removed, we can remove the base from the, actually it's assembly, it's floating assembly from the base. And first thing you got to do is remove 2 screws from this plate, which releases the cables from the housing, and then we can pull it all out from the plastic housing. We don't have to worry about 2 things being connected together. Let me try this. I already had it out, so it's just a matter of unhooking this transport screw here. It's got a big washer on the bottom of it, and if you can get it to unhook from the plastic, like right there, and then pull this one out there, and you can see it sits on these 4 feet, just one in each corner, and these 2 washers lock it in place. I already had the cover off, and it looks like we have 3 refit caps in here to replace. So let me get started on that. Does this board come out? I think it just pops out like that. Yeah, easy. So we got a 330 nanofarad, 10 nanofarad, and a 68 nanofarad. And I need to find suitable replacements. So I just found out I can clamp it in my vise here, and it just stands it right up for me, and I don't have to worry about damaging the tone arm in any way. It just sits up and it's ready to go. So I can work on this. Plus I can replace the signal cable. Easy enough out of this box. So we'll get that done. So what I did is I just chopped the ends, the spade connector ends off the old cable and attached them to the new cable. And this will retain the ability just to disconnect it. So we've got a new cable, ends all prepped, and it's ready to go on. So once that cools a bit, I'll just slap those on there and then reattach it. It gets attached here. Actually, we can do this right now. Right signal, right ground. Left ground and left signal. There we go. This is all silver plated. You can see the corrosion in the black. Not that we don't need to clean it. This will bite in and make contact. So we'll be good. Alright. Also, 3 new caps on this board, and eliminated eliminated 3 reefa caps. So I'll put this back together. This can go in here. Put this back together. I can reassemble this. So this cover goes on, hooks on the top. There it goes. And then a screw at the bottom. And then we're good. Alright, we're back together, got the cover on. This cable here, these wires, they were originally taped to the chassis. And they should be taped back because the chassis is like a ground plane and you want that right close to the ground. And I'll tape those wires back up so they're not hanging, because it can pick up stray hum just from hanging like that. Even though all the wiring's over on this side, still you want to keep it close to the ground. And got this crimped on. That's back together. It's anchored here, and this is our, let's test this for continuity just to make sure we got our continuity on our cable. And so let's go ohms. Left channel, what do we got? 652 ohms, perfect. Right channel, 653, so we're good. Really nothing else to do under here unless I want to get into a lubrication frenzy. I think everything's going to be working fine. We'll test this operation. If something's not working, then we'll come back and we'll do some lubrication, but I think I'll just leave everything alone the way it is. I don't see any problems here. Everything looks good. Even the motor, I think I'll just leave alone. I might add a touch of oil on the top bearing just to see how it make it, see if it's thirsty or not. But anyways, this can go back into the base. I think we're done. So these are the reefa caps. Anybody wondering what's a reefa cap? Well, this is a reefa cap. It's got reefa branding on it, and it comes in this yellow translucent kind of epoxy. What they do is you can see on the end the capacitor is made of foil and some kind of a insulator, maybe probably a film, plastic film, and it's rolled up in this kind of flattened shape, and then they attach leads on the end, and then what they do is they cover it with a probably looks like a sheet of plastic or something that has all the graphics and text on it. You can see it here. It's kind of folded over the top. And then they insert this all into a mold, and they inject it with some resin that cures. And the failure on these is it cracks, right? You can see the cracks on the sides, and it swells up. It's not flat anymore. It kind of bulges out. Same on this side. It kind of bulges out, and you can see that. And there's cracks that once it starts to bulge, it cracks out. And when it cracks out, what happens is it allows air, well, oxygen and moisture to get in to the internals of the capacitor, and then it just accelerates from there. Let's see if we can see it on this one. You can see it on this one too. All three of them have it. There's a crack here, a big crack on the bottom, and it is bulged out. It's bulged out quite a bit up to here, to the top here. This side, it's all bulged out and cracked. I don't know if the camera's picking it up, but I can see it. Here's the other one. It's all cracked. Now, oh, this was cracked right through on the side here even. So, yeah, and then moisture and oxygen gets in and starts to corrode inside, absorb oxygen, absorbs moisture, starts to swell, and then they leak. Once they start leaking, electrically leak, I mean, they start bleeding current through the dielectric, and what happens is that process continues, more and more current can flow through the dielectric, and what happens is the capacitor self-heats. When you get, this capacitor is rated at 250 volts RMS, so when you get 250 volts and you start getting a few milliamps of current leakage, you start to get some serious heating inside this cap, and when it starts to heat inside, it accelerates the process of increasing current flow. So if we could test these, we can test these right now to see if they leak current. I bet you they all do. 250 volts. Let's that's RMS. So let's go 250 volts times 1.414 is 350 volts peak. So let's test these at 350 volts and see how much current leakage we get. Alright, so there's my leakage tester, and it's set for 350 volts. Let's do the big one first. Connect it up, and then let's turn up to its most sensitive rate setting. Okay, so we're leaking around 5 microamps. I don't know if you can see that. The needle did jump up, and it is moving a little bit. It's kind of finding a happy spot there. It is twitching. So this is 100 microamps full scale, 10, 5, or less than 5 microamps, which is unacceptable for a film capacitor. It should be 0. So let's turn this off and discharge the cap. We'll try the next one. This one's the 68 nanofarad cap, so we're going up. And same thing, the needle jumped up on our most sensitive scale, and we're probably around 2 or 3 microamps. Not as bad as the 330 nanofarad cap, but it is kind of settling down around 0. So that leakage is kind of there, but it's very minor right now. So this one's the 10 nanofarad cap. Let's turn this one up. Same thing. We get a jump to about 2 or 3 microamps, and then it stays stable. So that should be 0, not 2 or 3. So overall, these caps aren't actually in bad shape. They're actually pretty good shape. I've seen them a lot worse. And these ones are, well, they are deteriorating, and they'll just get worse with time. So it's a good thing we got them out. I'll show you. I have in my bad cap collection. Yeah, I do keep bad caps. I think I got one here. Here's another one. This one is a 330 nanofarad. This one's got some serious cracking on the sides, you can see. This one's closer to failing. When they fail, the internal current goes higher and higher until the point where it starts to flame out and burn up. This one wasn't there yet, but this one's really severely cracked. Let's test this one, see how bad it is. Okay, going up. Alright, so I'm on the second highest scale, and it's already at 500 and, yeah, that's so it's over 500 microamps, which is half a milliamp, and that's at 350 volts. So as they deteriorate, the current leakage in these goes higher and higher, and in turn the internal heating of these capacitors goes higher and higher until it hits a point where it just flames out and creates smoke and fire. And probably what would happen before any of that happens is it would blow the fuse. I think these duals have a small fuse in line. I didn't even see it. I don't remember seeing one, but the fuse blows before the cap can flame out to the point where it can cause a fire. So anytime you come across these reefer caps in any equipment, you instantly replace them automatically without even testing them, because they're going to fail eventually. Sooner or later they're going to fail. Even if they test perfectly good today, they might not test good 10, 15 years. Here's an example of another reefer cap. This is a modern version of it. Come on, focus. And these don't suffer the same problems. You see there's no cracking on the sides. It's got the seals intact. So when you come across a blue reefer cap, these are fine. You can leave them alone. These will last indefinitely, or they should anyway. I was looking at the mat and I was thinking, well, it doesn't look too bad. But then I used a little bit of this cleaner. This is what I use for all. This is a rubber mat. And I gave it a little spritz. And you can see how much. Give it a scrub with a brush. You can see how dirty and filthy it was. Look at the brush is gray. That's how the brush should look. But once you rinse it off, it's all good. You'd be amazed how filthy these mats get. And they don't even look dirty. Just going to use some fresh double-sided tape on the platter for the mat. And in 20 years, when this deteriorates, you put some new stuff on. It's not a big deal. That's all we need. Just to hold the mat down from slipping or sliding around. Alright, get these off. Get it centered. And there we go. You can kind of feel the bump on each one of the three. Alright, got some amplification hooked up, got a record on, so let's try this out. Let's turn on our amplifier. You see our hum is gone? No, what's that? Well, our ground is not hooked up yet. Now it's quiet. That's full volume, got zero hum. Okay, so let's try this out. Flip up this little guard. We're on 33 now. And the pitch is off quite a bit. Let's turn this pitch down. Okay. Sounds pretty good. My big clubby fingers can't. Okay, sounds good. I haven't set up the tone arm yet, or I haven't done anything like that, so I might just do that. I'll check the weight. It might not be aligned or adjusted, so we'll try that next. But, let me try the auto stop while we're here. What happened? It stopped. Okay, dropping the needle. Okay, that's working. Auto stop, not returned. Okay, alright, just finished doing the test video, so that went really well. I think I'm done with this. It's working great now. I'm just going to wrap this one up here and get this one back to the owner. Well, maybe I got to shift that over sideways a bit. But it is done and I'm happy with it. So thanks for watching. Take care and we'll see you on the next one.